Here we have the progress of the prototypes of the prosthetic fingers. Firstly, the texture of the finger pads. We went from the original smooth finger pads to two other texture designs, horizontal grooves and miniature bumps on the finger pads. This was rejected as the bumps were sharp and potentially harmful. So we decided on the horizontal grooves design. Secondly, the materials used for the fingertips. Initially, the tip of the soft tip stylus was considered. Unfortunately, it is too narrow and not soft and flexible enough to grab an object. Therefore, we settled on jumping clay, a flexible rubbery substance that can be reshaped on a modified fingertip. Two types of jumping clay were further considered: the smooth clay and the clay with the polystyrene beads. We decided on the smooth clay as the clay with polystyrene beads became too rigid after drying. Combining the two texture and material that we chose, this is what we would get. Thirdly, the structure of the finger. The tip and side of the finger were modified to hold a thermal sensor. It has straight, slanted channels, as well as a channel to redirect the wires from the side of the finger to the top, minimizing the sideway expansion while still keeping the wires neat. However, we realized that the thermosensor would become an obstruction if we were to grab something by our fingertips, and it is more likely to feel heat at our palm area rather than our fingertips when grabbing something hot. So, we relocated the thermosensor here instead.
Two, one.
This is the velocity pressure sensor covered by a finger glove. When a force is exerted on the pressure sensor, the amount of pressure exerted will show up accordingly on the LED bar. This is the infrared thermometer, velocity pressure sensor, and LCD screen. This box stores the buzzer, Arduino Nano, battery, and the vibration motor. Input from the various sensors are converted into digital data readings in Arduino and show up on the LCD screen. A represents the ambient temperature, while T represents the temperature of the object, and these two readings are measured by the IR thermometer. When the IR thermometer measures the temperature above the set limit, it will sound off the buzzer and set off the vibration motor. P represents the pressure exerted on the velocity pressure sensor. The amount of pressure exerted will show up on the LCD screen as well.